Assalamualaikum warahmatullahi wabarakatuh. In the name of Allah, the most beneficent and the most merciful. Today is our 14th meeting, class 5, math subject, and I'm your math teacher, Mrs. Farah Nasir. Today our topic is LCM and HCF by division method. You have already learned the division method of LCM in your previous class. Page 57, 58, they both are regarding LCM and HCF of the numbers by division method. Page 57, question number 1, 2, and 3. 3 questions are there, and all the parts of these 3 questions are included in your scheme. Question number 1 is find the prime factors of these numbers using the division method, and then check your answer. Find the prime factors of these numbers. Prime numbers, which numbers are prime? The numbers which are not divisible by any number, but only by themselves. Like 2, 3, 5, 7, 11. These all are prime numbers. First, we simplify the given numbers into the prime factors, and then we show that after multiplication, the answer is the same that is given in the question. But we will use the division method. You are familiar by this method. 156, the number 156 is given. We start from 2 because at the end this is 6 and 6 is an even number. Even numbers are those numbers which we can divide by 2. So we start the division from 2. When we divide 156 with 2, 78 will be the quotient. Again, 8 is even number, so again we divide it by 2. After dividing 78 by 2, 39 is there. 39, now 9 is not an even number. It means that it is not divisible by 2. So we check 39 by 3. When we divide 39 with 3, the quotient is 13. Now we have complete the division of 156. We get all the prime factors. 2, 2, 3, and 13. These all numbers are prime numbers. 2 multiply by 2, multiply by 3, multiply by 13. When we multiply all these numbers, we get 156, which is a number of your question. Next part is 66. Again, 6 an even number, we divide with 2. 33, when you divide 66 by 2, 33 will be the quotient. Now 3 is not an even number, so we try with 3 and we get 11. Now we have 3 prime factors, 2, 3, and 11. 2 multiply by 3, multiply by 11. When we multiply all these numbers, we get 66. Next number is 475. Part C is 475. Definitely at the ones place there is 5. It means that it will be divisible by 5. We start division from 5. And when we divide 475 with 5, 95 will be the quotient. Again at the ones place there is 5. It means that again 95 will be divisible by 5. When we divide 95 with 5, 19 will be the quotient. And 19 is a prime number. 19 is a prime number, so 19 is only divisible by itself. The prime factors of 475 are 5 multiplied by 5 multiplied by 19. Prime factors of 475, 5 multiplied by 5 multiplied by 19. Although 475 is a bigger number, but only there are 3 prime factors of this number. Come to the part D. 212. Again at the ones place there is 2. It means that we will start the division from 2. When we divide 212 with 2, what will be the quotient? 106. Again, at the ones place there is 6 and 6 an even number. So we divide it by 2 and we get 53. Now 53 is a prime number and we cannot divide 53 by any number. The factors of 212 are 2 multiplied by 2 multiplied by 53. Part E is 94. 94. 4 is an even number, and again what will we do? We start division from 2. After dividing 94 by 2, the quotient is 47, and 47 is a prime number. So only the factors of 94 are 2 multiplied by 47. The last part of this question is 164, part F. 164, 4 is an even number. So definitely we will divide this by 2. After dividing we get 82. Again 2 is on the ones place and 2 is an even number. We divide 82 by 2, 41. There are only 3 prime factors of 164. 2 multiply by 2 multiply by 41. Clear? Yes, now come to the question 2. In this question, already the factors are given. We will make the partners to make our solution easy. We only make the partners of the number and we multiply to get the number of which the factors are given. In part A, 2 multiplied by 2 multiplied by 5 multiplied by 5. 4 numbers are there. So we make the partner 2 and 2 and 5 into 5. We enclose 2 and 2 in one bracket, 5 multiplied by 5 in the other round bracket. 2 2s are 4 and 5 5s are 25. After the multiplication of 25 and 4, 100, it means that 2 multiplied by 2 multiplied by 5 multiplied by 5 are the prime factors of 100. In part B, again 4 numbers are given. 2 multiplied by 2 multiplied by 5 multiplied by 7. Again we make the partners 2 with 2 and 5 with 7. 2 multiplied by 2 is 4 and 5 multiplied by 7 is 35. 4 multiplied by 35 is 140. Only we use these brackets for the convenience of our multiplication. These brackets make our solution easy. So that's why only we use the brackets. Otherwise, when you multiply 2 multiply by 2 multiply by 5 multiply by 7, the answer will be same 140. In part C, 3 multiply by 3 multiply by 5. Now the partners are 3 and 3 and 5 is left. 3 3s are 9. 9 multiplied by 5 is 45. So the factors of 45 are 3 multiplied by 3 multiplied by 5. And the last part of this question is 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5. 5 numbers are given. We make the partner 2 with 2, 3 with 3 and 5 is left there. 2 times 2 is 4, 3 times 3 is 9 and 5. 4 9s are 36 multiplied by 5. Answer is 1 80. The factors of 180 are 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5. In these questions, already factors are given, and after making the partner and the multiplication, we find the number the way in which the factors are given to us. Question number 3. In this question, write the HCF. HCF is the highest common factor, and you are familiar with this because you have done HCF in class 4. Highest common factor, HCF of 2 or more number is a largest number, which is a factor of all of them. If 2 numbers are given or 3 numbers are given to us, we will find the highest common factor in between these 2 or 3 numbers, and that number is called the HCF of all the numbers. For example, if we have 20 and 35, 2 numbers, what will be the factors of 20? 4 times 5 is 20, and same 35, 7 times 5 is 35. 5 is common in both 20 and 35. So the HCF of these two numbers will be 5. Is it clear? Okay, now we start doing the question. Question number 3 is regarding HCF. There are 4 parts of this question. Part A is 18, 27 and 36. 3 numbers are given, but in the question they didn't mention that find the prime factor and after this find the HCF or convert these numbers into their prime factors. So we directly calculate 18. What are the factor of 18? 2 9s are 18, 27, 3 9s are 27, 36, 4 9s are 36. And we see that 9 is common in all these 3 numbers. So HCF of these number will be 9 because 9 is the common factor and the highest common factor in all these 3 numbers. Part B is 12 and 30. 12 and 30. The factors of 12, 2 multiplied by 6 and 30, 5 multiplied by 6. 6 is common in between these two numbers and 6 is the highest common factor of 12 and 30. In the next part, again 3 numbers are given, 27, 54 and 18. The factors of 27, 3 multiplied by 9, 54, 6 multiplied by 9, 18, 2 multiplied by 9. If you see all these 3 numbers carefully, then you can understand that these all are numbers which are in the table of 9. So you can easily split 27, 54 and 18 in the factors of 9. 27, 3 into 9, 54, 6 into 9 and 18 is 2 into 9. So again the highest common factor in between these 3 numbers is 9. The last part of this question is again there are 3 numbers 18, 38, 16 and 14. 38, 16 and 14. Part D, we have the factors. We have the numbers 38, 16 and 14. And you see that all these numbers are divisible by 2. The factors of 38 are 2 multiplied by 9, 16, 2 multiplied by 8 and 14 is 2 multiplied by 7. The common number in all these 3 numbers is 2 and HCF of these 3 numbers is 2. Again, I am repeating this question. We have three numbers 38, 16 and 14. The factors of 38 are 2 multiplied by 19. The factors of 16, 2 multiplied by 8. And the factors of 14, 2 multiplied by 7. 2 is common in all these three numbers. So HCF of these three numbers will be 2. We have finished page number 57. I told you there are 3 questions on this page and all the parts of these questions are included in our scheme, and we have finished this page. LCM and HCF. LCM by division method, prime factorization method. Now we have page number 58 and division method of the HCF. It means that the numbers are given to us. We simplify them by division method, and after finding the LCM, HCF, we will also calculate the LCM of the same number. There are 3 questions, 4, 5 and 6 in this page 58, and all the parts and all the questions of this page is included in our scheme. Question number 4 is break these pairs of numbers into their prime factors, then find their HCF and LCM. Again, this question is same that we have done question number 1 on page 57, that division method and prime factors. But in this question, we also calculate the HCF and LCM both. Part A is 64 and 148. First, we find the prime factors of 64 by division method and also the factors of 148 by division method. And after finding the factors, we calculate the HCF and then LCM. Also remember that the formula of the LCM is HCF multiply all the other factors. It means that for the LCM, it is necessary that first we find the HCF and then we calculate the LCM. 64. The factor of 64 prime factors, we start from 2. When we divide 64 with 2, 32, then again with 2, 16, again with 2, 8. 8 is divisible by 2, 4 is divisible by 2, and 2 also divisible by 2. So the factors of 64 are, how many 2's are there? 1, 2, 3, 4, 5, 6. It means that when you multiply 2 with 6 times, then we have 64. 148. When we divide 148 with 2, 74. Again 74 is divisible by 2, and 37. 37 is not divisible by 2 because it is a prime number. The factors of 148 are 2 multiplied by 2 multiplied by 37. First, we find HCF, that I told you before that in this question, it is necessary for the LCM that first we calculate HCF. It will be easy to find the LCM. So the HCF will be 4 because 2 2's are common in 64 and 148. HCF is 4. Now we write the formula of the LCM. HCF multiply all other factors. HCF is already 4. Then you see the remaining numbers in 64. How many 2's are left there? We already select 2 2's for the HCF. How many 2's are left? 4 2's are there, and 37 in 148. So all other factors, we write there 4 2's and 37. After the multiplication of 4 into 16 into 37, we have 2, 3, 6, 8. The LCM is 2, 3, 6, 8. LCM of 64 and 148 is 2, 3, 6, 8, and HCF is 4. because HCF highest common factor and LCM is least common multiple. So least mean we write all the numbers, all the factors of 2 or 3 numbers are given, we write all the numbers of 3. B part is 63 and 108. 63, at the ones place there is 3, it means that it is not divisible by 2. We divide with 3. 21, again 21 is divisible by 3 and 7. The factors of 63 are 3 multiplied by 3 multiplied by 7. 108, 108 divisible by 2, 54. Again we divide it by 2, 27. Now 27 is not divisible by 2. We start division with 3. 9 and 9 again divisible by 3 and 3. Definitely 3 is also divisible by 3. The factors of 108 are 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3. Now how many 3's are common in 63 and 108? 2, 3. I also highlight these numbers which are over HCF. 3 multiplied by 3. HCF is 9. Again, we find the LCM. The formula is HCF multiply all other factors. HCF is 9. In the first 63, you see how many numbers are left there. Only 7 is left. So we write 7. And 108, how many numbers are left there? 2 multiplied by 2 multiplied by 3. We write also 2 multiplied by 2 multiplied by 3. Now the LCM is 9 multiplied by 7 multiplied by 2 multiplied by 2 multiplied by 3. After the multiplication of all these numbers, the LCM becomes 756. The LCM of 63 and 108 is 756 and HCF is 9. HCF will always be a smaller number because the highest common factor. So that's why the highest common factor will be the smaller and the least common multiple will always be a greater number. Now part C. Part C is 26 and 96. 26, only the factors of 26 are 2 multiplied by 13. And 96, 6 is an even number. Start division from 2. 48, 48 is divisible by 2. Then 24, 24 also divisible by 2. Then 12, 12 is divisible by 2. 6 divisible by 2 and at the end 3. The factors of 96 are 2 multiplied by 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 3. And the common factor only 2. The HCF is 2 in both numbers 96 and 26. The LCM HCF multiplied by all the other factors. HCF is 2 and we see that which number is left in 26? 13. 13 is left there. And how many numbers are left in 96? 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3. We write all these numbers and after the multiplication you see that the LCM of 26 and 96 is 1248. 1248. The LCM of these two numbers and HCF is only 2. Part D, the last part of this question is 27 and 130. 27 and 130. Make the factors of 27, the prime factors. 27 is divisible by 3, 9 and 9 is also divisible by 3. The factors of 27, 1 multiplied by 3 multiplied by 3 multiplied by 3. Same 130. 130 we divide it by 2, 65. 65 is not divisible by 2, definitely. The ones place is 5, so it will be divisible by 5. We divide 65 with 5, 13. The factors of 130 are 1 multiplied by 2 multiplied by 5 multiplied by 13. But there is only one number, 1 is common in these two, 27 and 130. No number is common in between Then, so HCF will be 1. LCM. LCM is HCF multiplied by all the other factors. HCF is 1. How many numbers are left in 27? 3 multiplied by 3 multiplied by 3. And in 130, also 2 multiplied by 5 multiplied by 13. Multiply all these numbers. The answer is 3510. The LCM of 27 and 130 is 3510 and HCF is only 1. This is the last part of this question, question number 4. Question number 5. In question 5, the factors are already given. We find the common factor and then we find the HCF of the given factors. There are 3 parts in this question, A, B, C, and all the parts are included. The question is, these are numbers that have already been broken down into their prime factors. Quickly find the HCF of each pair. The first part is 2 multiplied by 2 multiplied by 2 multiplied by 5 and 2 multiplied by 2 multiplied by 3 multiplied by 5. I highlight the common factor for you in this. You see that which numbers are common. 2, 2, 5. Common factors are 2, 2 and 5. So the HCF will be 2 multiplied by 2 multiplied by 5. 20 will be the HCF of these broken down prime numbers. Come to the part B. The first prime numbers 2 multiplied by 3 multiplied by 3 multiplied by 5, and the second 2 multiplied by 3 multiplied by 5 multiplied by 7. And I highlight the numbers 2, 3 and 5. 2, 3 and 5, these 3 numbers are common in these 2 pair of prime factors. 2 multiplied by 3 multiplied by 5 is 30. 2 3s are 6 and 6 5s are 30. So HCF of these given prime factors is 30. The C part of this question is 2 multiplied by 3 multiplied by 5 multiplied by 5, and the other 3 multiplied by 5 multiplied by 5 multiplied by 7. The highlighted numbers are 3, 5, 5. 3, 5, 5. These 3 numbers are common in these 2 prime factors. After the multiplication, 3 multiplied by 5 multiplied by 5. 3 5s are 15 and 15 5s are 75. So the HCF of these prime factors is 75. Question 5 is completed. Now come to the question 6. This is same that we have done question 5, but in this 3 numbers are given, 3 prime factors are given, and in this we will calculate the common factors and the HCF. The first part is 2 multiplied by 3 multiplied by 3. Second prime factors are 2 multiplied by 2 multiplied by 2, and the third one is 2 multiplied by 2 multiplied by 3. And I highlighted 2 for you because only 2 is common in between these 3 factors. So HCF will be 2. B part and the last part of this question, 2 multiplied by 2 multiplied by 3 multiplied by 5. 2 multiplied by 2 multiplied by 5 and 2 multiplied by 3 multiplied by 3 multiplied by 5. The highlighted numbers are 2 and 5 only. 2 and 5, they both numbers are common in these prime factors. So the HCF will be 2 multiplied by 5, which is 10. Okay, dear students, today's topic is finished. We have done page 57 and 58. both pages have the same concept about the LCM and the HCF. You have already done LCM by division method and HCF by division method in your previous class. Only one numbers are given. I think only one number is given in your previous class, but in this section we find the LCM and HCF of more than 2 or 3 numbers. The formula of LCM is HCF multiplied by all the other factors, and HCF means highest common factor. All of you are become happy when you listen that there is no homework today, no assignment. I have done all the parts and all the questions for you. Enjoy your past. Okay, students, Allah Hafiz.